Next, we're going to talk about the continuous uniform probability distribution. As you might expect from its name, the continuous is for continuous random variables, and the uniform corresponds to the fact that the height of the curve that we normally look at for a PDF or a continuous random variable is going to be equal across all possible values of y. And so this is what the uniform PDF looks like in a very simple form, where we have f of y is equal to 1 over beta minus alpha. Beta and alpha are Greek letters. And this is defined upon the region of, or the set of possible values of y between alpha and beta. So for example, alpha could be 0, beta could be 1, and in that particular case, f of y will be equal to 1 over that region. Or alpha could be, let's say, we'll say -1, and beta could be 10. And in that particular region, f of y will be actually equal to 11, 1 over 11. For any other possible values of y outside alpha and beta, f of y is equal to 0. And in fact, we've actually seen this kind of a PDF before, but for specific values of alpha and beta. Here in general is what this PDF will look like. Again, the height of the curve, you could say, between alpha and beta is 1 over beta minus alpha. The area underneath the curve is equal to 1. And how do you find that? Well, you could use obviously integration, but more simply, you could find the area of a rectangle, base times height, to show that. One could also show, and I would like you to do this on your own, that the expected value of y, or in other words, mu, the population mean, is equal to alpha plus beta divided by 2. And the variance of y, or sigma squared, is equal to beta minus alpha squared, all that divided by 12. Please make sure you can do that on your own again. And so what we've seen this particular kind of PDF is with respect to the miles per gallon example that we saw before, where if x was a continuous random variable denoting the miles per gallon of a particular type of car, then f of x is equal to 1/10 between, for x between 25 and 35. And then using this PDF, we actually found probabilities as we did before. Since we did it before, I'm not going to go through further details. So that's really a quick introduction to what perhaps is the simplest probability distribution function for continuous random variables.